The semester, various models and simulations were developed in order to understand the workings of the inner ear, specifically Bast valve and the role it plays in Meniere's disease. Meniere's disease is a disorder of the inner ear that can lead to dizzy spells, ringing in the ears, and hearing loss. Some studies have been conducted to determine the cause of it, but it is still unknown. We are trying to determine if Bast valve plays a role in causing Meniere's disease. We are mainly focused on this inner ear portion shown in the box. This includes the utricle, semicircular canal, and Bast valve. The need of this project is to understand how Bast valve works. There are only proposed hypotheses on this currently. The one our team was trying to prove is that Bast valve acts as a pressure regulator. It is normally closed, like shown in the first image of the histology scan. As pressure builds, the bottom of the valve distends to relieve pressure. This bottom can only distend so much since it'll reach bone. In an extremely diseased state, as the pressure increases, the top of the valve will start to deform and eventually with enough force will close the opening. This will lead to swelling and potentially Meniere's disease. Our team constructed 3 different models to verify this. The first was a 2D COMSOL model made from the histological scan. The second was a 3D COMSOL model to verify the findings of the 2D model. And the third was a 3D SolidWorks model to be 3D printed and used in physical testing. The last 2 3D models were geometrically simplified, but the dimensions are accurate from the histological scan. The 2D COMSOL model produced this result of the top lip of the valve deforming as the pressure gradient increased. This supported our hypothesis that the valve will close in with enough pressure, resulting in swelling seen in Meniere's disease. The 3D COMSOL model result shows the fluid velocity gradient at the beginning of the valve. Since the bottom is distended as much as it can be, the top will deform and close the valve, proving the same results as the 2D model. Next, the team wanted to make a 3D model in anatomically correct material. To test out our model to see if it was printable, we first printed in PLA in 2 different orientations with different supports. The model printed vertically with less supports worked better. This was noted, and Stratasys will be printing a model in anatomically similar material so it can be tested in the future by Johns Hopkins Medicine.